The US-Germany collaboration is on studying high-temperature ceramic coatings, and this is looking at it under thermal gradients and mechanical loads. It was funded by the National Science Foundation's Catalyzing New International Collaboration initiative and involves several parties, including myself from the University of Central Florida, Dr. Annette Carlson from Cleveland State University, Dr. Marian Barsch from the German Aerospace Center in Cologne, and it has the participation of Dr. Jonathan Almer from the Argonne National Laboratory. It is a really synergistic collaboration because we all have complementary expertise in this field.
The German Aerospace Center, or DLR, was significant for this project because they have experience in applying these thermal gradient and mechanical loading to these thermal barrier coatings. So they had the prior experience applying these loading conditions, while we had the prior experience taking the in situ strain measurements. So what we did is we decided to collaborate, use our knowledge of taking the strain measurements and their knowledge of applying the loading conditions and combine them together.
We were working to develop an apparatus that includes both thermal gradient and mechanical loading to test in realistic environments a thermal barrier coating on a traditional substrate for turbine blades for jet engines. We also used a synchrotron X-ray beam to provide very bright X-rays to be able to analyze through transmission the strains and subsequently the stress that the coatings are feeling during a representative 90-minute flight cycle. A great challenge that came with this project was being able to do the scope of the work in such a short amount of time. So in less than 6 months, we went from here to Germany to Chicago to be able to build this setup, which is a very rapid time scale to be able to achieve something of that magnitude. We were working at the German Aerospace Center with Dr. Marian Barsch and a team of other engineers there to help develop our system for implementation at the synchrotron. DLR has a long experience working with TGMF, or thermal gradient and mechanical fatigue setups, one of the only places in the world where you can find such a system that's used to rapidly test and characterize different turbine samples. While we were there, we were working directly with both Janine and Carla and Dr. Barsch. We were able to learn a lot from the previous decade of research that DLR has done in developing their system, learn what does work, what doesn't work, and what was the most effective way to collect measurements. And then we took our expertise with the synchrotron and taking X-ray diffraction measurements, and we were able to blend the two together to be able to form an apparatus that proved functional and provided great results in just less than 6 months. We worked with a number of great scientists and researchers while we were in Germany. Specifically at the DLR facility in Cologne, we worked with Dr. Scholz, who is one of the experts in coating technology, and it was incredible to see the machinery that's available and the process he goes through to make our samples ultimately. And we look forward to working with him in the future, as he's going to be working with us to provide samples for future experiments as we continue the collaboration.
In Germany, we actually had the experience of joining Dr. Ragavan in some of her meetings. So we got the experience that most graduate students don't get of sitting in and the initiation of an international collaboration. So we got to sit down with her in our meeting at Jülich Laboratory in Germany, which have some world-renowned scientists there as well. So, which is not an opportunity that most graduate students get to go through. There really wasn't a lot of large cultural hurdles to get over when going to Germany. There was some cultural differences that are very beneficial for us to being exposed to. For instance, there's a different work environment whichever foreign country you go to. So being exposed to how other people work in different work schedules, work ethics, makes you think of things at a different perspective when you're back home. My favorite visit was being able to go down the Rhine River on a boat where we could see castles on both sides, as well as just walking every single day, walking by Roman ruins. You just get to see history on a daily basis that you don't get to here at home. So at the end of the Rhine River cruise, we actually got to get out and hike up a hill that was above a small village and walk through a castle that's been around since 1200.
Our lab here, under the direction of Dr. Sita Raghavan, has a long list of experience working at Argonne National Labs, particularly with the Advanced Photon Source. So our team was able to bring to the table the experience working at a synchrotron, being able to take X-ray diffraction measurements, and also to be able to show how to do strain analysis based on X-ray diffraction patterns upon the completion of this experiment.
The technical objective actually had two sub-objectives. The first one is to apply real-world conditions. So in order to do that, we actually applied a thermal gradient across the thermal barrier coating, as well as apply a mechanical load to it. So this was all being done while the second objective was to take in situ, in-cycle strain measurements using the synchrotron X-ray at Argonne of these various internal layers. The most difficult part with respect to Argonne was being able to work an experiment 24 hours a day for 4 or 5 days. Being able to run an experiment around the clock and still be able to think on your feet. We were able to work in and around some of the best scientists at the Advanced Photon Source, and many of which were very interested in our project. While we were there setting it up and doing our initial testing, we did have a lot of the people there at the Advanced Photon Source stopping by just to see our project, including the director of the entire Advanced Photon Source at Argonne.
We have started to achieve research outcomes from this project in terms of the graduate students being able to present at conferences. We've started publishing papers on the work that we've done. The graduate students have been mentoring undergraduate students through a number of programs here at UCF, like the Excel Ramp program as well as the UCF Learn program. The undergraduates involved in this have actually produced some research posters and given some presentations which have an outreach to the community of researchers here at UCF. And through this, we intend to get the word out on how international collaboration actually benefits technical advances in the field.